this episode, I talked to Mike Connaughton, Senior Product Manager, Network Solutions at Leviton. We discuss how AI is different from traditional computing, how it affects the design and operation of data centers, and what challenges and opportunities it brings to the industry. We'll discuss how AI computing requires more power, cooling, and connectivity than conventional computing, how data centers can optimize their infrastructure and operations for AI, and what the future of AI and data centers look like. So, just so you know, side note, behind the curtains, that intro was written by AI after it reviewed the transcript of our interview. I thought it appropriate to give it a go considering our topic. So one of the questions I like to start out with is, if I were to visit you in your hometown, where's somewhere you might take myself or some of our listeners if they were to come visit you, and why would you choose this place?
Yeah, so I got to say, where I sit, the plant's in Fuquay-Varina, which is a suburb of Raleigh. I live in the next town over in Holly Springs, and there's a lot of good restaurants actually right around here. But if it's left to me, I pick My Way Tavern in Holly Springs. And, big reason that I mentioned a bit ago, I'm from Boston. I'm from the Dorchester section, which is inner city Boston. And My Way kind of has that kind of neighborhood pub vibe that I'm used to. It's people are always friendly that are in there, both the workers as well as the patrons. You end up just kind of striking up a conversation with whoever is at the next table half the time. A lot of TVs, so there's sports on. There's a lot of times there's live music, and the food is good because I'm like you. I like to have meetings at lunch. I mean, to me, it's a little more casual, gets you out of the office, a little more relaxed, and you can have a more, let's say, natural conversation instead of something that's forced. That's probably my place to do that around here.
What's your favorite item to order there, or items?
They get a lot of things on the menu that are good, but I'd say what I get the most often would be a buffalo chicken wrap or fish and chips. But either way, I get the homemade potato chips because those are awesome.
Yeah, I like trying fish and chips at places and kind of seeing how they do the breading and the chips and all that. So cool.
Right. I mean, it's a pub, and actually one of the guys, he's one of the sales guys for us that comes to town every once in a while. And he's a foodie, so you always have to be careful when you're picking a restaurant. Actually, typically you don't get to pick the restaurant when he's with you.
Oh,
we went there. He actually complimented the food there.
Oh,
and
nice.
That stays with me. So a foodie enjoyed the food at My Way. So the fish and chips coming out of the other side of the bar was very, very good.
Well, that's just something. Since it's a pub, you have a favorite beverage you like consuming there?
I actually rotate through them because it's another thing I didn't get into until I moved down here to North Carolina. It's been 16 years now, but the whole kind of microbrew thing. And there's a lot of them around here. But I'd say my favorite at the moment is Pernicious, which I think is Wicked Weed is the brewery that makes that one.
Okay. Well, so now's the time when I come up with some really cool transition point from eating and the topic. But it's not too hard with this one because AI is mentioned in every single area of life, no matter what you're talking about. Almost all my guests talk about it now. And you hear it on the news and talk about it at work and with your kids and everywhere. So it's not too hard, maybe AI is helping the restaurant come up with a new menu, or maybe it's helping them manage their HVAC. Who knows? But it's definitely involved in some point in the restaurants, in your life and my life. But one thing, I mentioned this in the introduction. One thing I never really thought about was AI's impact on data centers, and that AI is a form of computing. And I thought it was just like, the server that runs, our files or whatever. But hearing you on a webinar you did for Gray Bar got me thinking, I don't think I understand this topic. So my first question to you, Mike, is how is AI computing different than what normally happens in data centers, or what's been happening in data centers for 20, 30 years?
Yeah, so the big thing is really the kind of concentration of power into those specific servers. That's usually I would say the thing that most people notice initially is the power usage. A traditional data center would have something like, 10 kilowatts per rack. That would be kind of a design constraint, and that would support all the switches and servers that are in that rack. When we talk about AI, the latest designs are talking about 10 times. They're talking about hundreds of kilowatts per rack. I mean, today it tends to be kind of 50, 60, 70 watts, but it's going up by the day. So that's kind of the first thing. They're very power hungry applications. The second thing people tend to notice is there's a ton of optical connections. The kind of bandwidth capability of copper has stopped keeping up, even in rack with AI networks. And the reason behind that, or part of the reason behind that, is a lot of parallel processing going on. So they're using GPUs, which historically they were developed for video games. They're graphical processing units. So they can, take a lot of information simultaneously and do something with it. Where a CPU, your computing, traditional computing chip, does things serially. It takes in one piece of information, maybe it stores it, another piece comes in, another piece comes in. So it's really those two things, and they're related to each other, that makes the AI network different than the traditional data center network. So the traditional network is compute. There's not really a lot of, at least parallel processing that's going on. So, in the bigger data centers, there's things called east-west traffic, which means it's staying in the data center. And in the case of AI, it's probably inside the cluster, but it's just bouncing around in between racks, further and further refining the data. The kind of typical example people talk about AI is deciding what's in a picture. Is that a picture of a cat, or is it a bridge, or is it a tree? And it learns that internal to the network. It just bounces around back and forth and makes decisions. So there's a lot more east-west traffic going on. Inordinately, orders of magnitude more east-west traffic going on than north-south, which is the traffic that leaves the data center and goes out to the rest of the world. I'd say those are the significant differences between an AI, the compute part of an AI data center than a traditional data center.
So you mentioned GPUs, so that's interesting. So are they using GPUs to do the computing? I mean, to do the thinking for AI? Is that what you're saying?
Yeah, because it's, when you think of, it's essentially it's a bandwidth problem.
Sure.
So they're, it's another kind of historical lessons. It's not necessarily new. It's been talked about for many years in the compute industry, but kind of neural networks. So trying to reproduce what our brains do. So there's lots of parts of the brain doing lots of different things, but ultimately it's got to come together and output into one thing. And you're limited by how much bandwidth, how fast can we get that information through that network. And GPUs process data by design, process data much faster than CPUs. So they were, again, originally designed as they're still called graphical processing units, but that's not what they're doing anymore. Now it is strictly, predominantly data. You're just pumping data through it and asking it to do things a little bit differently than we asked it to do 20 years ago when they were first developed.
Well, that's pretty cool. And my kid has built a computer and obviously put a really good GPU on it. And yeah, you had to have a fan or two for that particular, for that, right? Whereas the computer I built or whatever had 20, 30 years ago didn't really need that.
Every 25-year-old in the world knows who NVIDIA is because they made the graphics cards that they wanted for their gaming computer.
Yeah.
Now NVIDIA is famous for a whole other reason.
Yeah, NVIDIA's made a good name for themselves. All right. Well, so thanks for that. That's a good intro. What are some of the biggest challenges faced by data center managers and operators, as they start to support more need for this kind of computing?
I mean, the biggest challenge they actually have today is getting the chips. If we kind of leave that to the side and assume they can get the chips, the biggest challenge they have in implementing it is really the power. It's so power hungry. The chips and then the servers that are built around the chips, the server are super power dense, which one of the kind of outputs of that is they get hot. So along with the power for the chip itself, you need power to cool the chip. So these things tend to be escalating issues. So, and then the other issue that has come out of that is that there's not enough power available in many of the traditional locations that a data center sits, or a company may have an existing data center in, city X, and they want to ramp up. There's not enough power, so they got to move to another place to get that power. So that's adding emphasis to things like latency. So, again, these transactions happen in parallel. So the timing of how that information comes in is critical. So those are the kind of the big things, the power and the latency. Actually, it was a good presentation at Data Center World last April. The Department of Energy put it on, and they did a study, I think it was in 2015 or 2016, right before AI started having an impact. The growth of AI data centers started having an impact in the power usage. And basically, they created this model to forecast power demand kind of by region in the U.S. And part of it's just power generation, electricity. But interestingly, there's also water. Water is used as to aid the cooling of these data centers. So it's having an impact on the water usage in these regions as well. So it was a pretty interesting presentation that they delivered.
Yeah, I think you all shared a link to me for that, so I'll put that in the show notes. It was pretty interesting. I kind of read through most of it there. So I think one of the other things you talked about is space an issue because of the connections and all that, or is it an issue?
Well, there's space becomes an issue in the opposite way. I mean, one of the, if you think of the physical size of a traditional data center, so you're asking about some of the differences, they may have 5 megawatts available for a data center, and they thought that they were going to be able to support 100,000 square feet. Well, it turns out that those AI processes require so much power. Now they're only getting a couple of rows. So the rest of that space, I've seen examples where the rest of the space basically becomes storage. Like they don't have enough power to run any more computers over in that part of the data center anymore.
Oh.
So that it's kind of fundamentally changing how the networks are physically laid out. It's not just kind of processing and power. There are some kind of fundamental design changes that are in the throes of being done. It's happening really quick. That's the other part of it. I mean, there's everybody likes to talk about best practices. Well, it's kind of too new. Nobody really knows what the best practices are yet. We're still figuring that part out. So it's depending on your point of view, it's either scary or it's kind of neat. I'm on the it's kind of interesting side of that coin.
Yeah. All right, let's go back to real quick. You talked about latency, and I think what you were, let me see if I understood what you're saying. So a lot of the computing happens in a few certain areas in the U.S. right now. Like Virginia is a big place, right? I think, for example. But are you saying that because the power demands are also high there, right? Because you got DC and big cities right around there. So are you saying that like it's hard to just move that to Kansas or Missouri because now you have a latency problem because where the computing is? Is that what we're talking about?
Yeah, I mean, it's not even that far away necessarily.
Okay.
I mean, one of the alternate sites, for Northern Virginia is, and I forget the county, Prince George maybe, but it's in Maryland.
Okay.
Which has become this up and coming thing. So it's attractive. The initial attraction right now is there's power available because, Loudoun County in Northern Virginia, they're tapped out for the time being. So you got to go someplace new. But if I have my existing data centers in Loudoun County and I'm going to build this new piece of it, because it's a new physical building. But from a network perspective, it would be optimal if they were connected completely together. So as far as the networking transactions were concerned, it doesn't know I'm going from building 1 to building 2, 20 miles away. And that's where the latency comes in. Now, instead of it going to the other side of the building, it's leaving the building, crossing a state border, and going someplace else. So, minimizing the latency within the data center, but at some point you have to leave it. So minimizing the latency outside the data center. And that's where kind of site selection becomes important. Yeah, you could put it in Kansas City, you could put it in Pennsylvania somewhere. The closer, the better. So that becomes that decision that people are going through now. How close can I be and still have everything else that I need to support my data center?
I saw some post or something, I don't know, who knows where I saw it, but something about every time you use AI, you use a gallon of water. I'm curious, just kind of the, I don't know, perspective on water usage in that. Is it recyclable? Is it, what kind of water usage is there really in this world?
It depends. How's that for an answer?
Yep, perfect.
It's not always water per se. It's fluid. So it depends on the type of cooling that you're doing. So if you think of just in your house, an air conditioner. So the point of it is to get the heat away from where you don't want it and, pump it out to where you do. So again, in your house, you're taking it out of your living room and you're, pump it out into your backyard. And the fluid is the mechanism to make that happen. In your house, it's air. You're pumping air through. It goes out into, it depends if you have a window air conditioner. It's going to your window, and then there's a heat exchanger of some sort that happens in that space. Typically, there's some type of fluid. Historically, we talk about Freon or something in a air conditioner or a refrigerator, for example. Well, you got to scale that up, and now there's one, much bigger spaces, and two, much, much hotter. So there's always been some amount of water, I'll say, being used for the cooling mechanisms. So some of the liquid cooling is what we call like liquid assist. That's very popular today. So it's very similar to like air conditioning, but you would the heat exchanger would be on the door of a cabinet, for example. So you would run piping to get the liquid out to that cabinet door and then just pump it through the heat exchanger, which is some other part of the data center. The next step up in efficiency for these very high power things is direct-to-chip cooling. So there, instead of it just being the door of the cabinet, you're bringing it either right to the chip, that GPU, or very, very close to it. So there might be a heat sink on that server that you're running fluid to that and drawing the heat out, and it goes back to a heat exchanger. The latest type that people are talking about now, latest is the newest, is immersion cooling, which is essentially you have a tub, you have a bath in the data center, and you lower the server into it. So it's not water exactly, but it's liquid. Okay. So it's some kind of dielectric. So the entire computer, if you think of it in that sense, is sitting in the fluid. And then the fluid itself gets pumped through pipes, again, out through some kind of exchanger somewhere where it can take the heat out. So for all of them, there's a cost trade-off. The heat exchangers are the least expensive of those, the easiest to install. But they have a max. It's something like, and I'm not certain of the numbers, but it's in the tens of watts per rack. That'll get you up into the 20, 30 watts per rack cooling. You're getting above that, doesn't work. So then you got to move into the direct-to-chip. When that runs out of its capability, now you're going into immersion cooling. So that's a lot of activity, a lot of work's being done around the immersion cooling. What's the best way to do it? There's various types of that. Again, there's a water component of it, but it's not all water. And there's, for the most part, it's recycled. It's just kind of in a system, and it pumps through. But there does have to be some replenishment that happens there, and that's one of the things that separates, some versions of it from others. It can keep its same, static amount of fluid longer, so you don't have to keep replenishing it.
Let's touch on, go back to power. So we talked about the
Mm-hmm.
need for power. So what are data centers starting to do to ensure that they have enough power that is reliable?
Yeah, kind of the the biggest eye-opening story was AWS earlier this year. They bought a nuclear power plant in Western PA, which is 900 megawatts of power. Again, usually at the traditional data center, we're usually talking about 3, 4, 5 megawatts of power. AWS bought a power plant that can support a 900 megawatt supply.
That's crazy.
Now, it's insane to think about. It's AWS. They're the biggest kind of data center provider in the world. So not everybody has the means to go buy, or even the need, honestly, to buy an entire nuclear power plant. But the thing that's interesting to me that you're seeing become real is what's called SMRs, small nuclear or small modular reactors. Equinix just cut a deal a couple of months ago with a company called Oklo for a few hundred megawatts of power. It's kind of hard to tell, 100, 200, 300 megawatts of power. And to me, what's interesting about that is it's basically taking an existing technology, which is the way the Navy has powered ships for several decades at this point. Any nuclear-powered ship has got a small nuclear reactor on the ship. You're essentially taking that technology, taking it off of a ship, putting it on land, building a business park around it to support kind of a target customer. So there's kind of regulatory issues that are still being resolved, but seems like a strong business case. When we talk about clean power, with trying to keep carbon neutral as much as possible, nuclear power is one that's got a very strong performance when you start looking at atmospheric carbon and so on. It's a very clean power source from that perspective.
Yeah, it's pretty wild. Well, besides small nuclear plants, which just blows my mind, but makes sense. What else might they be doing?
I mean, there's a lot. You are seeing a lot of, again, I call them business parks, but kind of specific locations looking at just supplying their own power however they can. So you've seen for a lot of years solar, you see wind, a lot of wind coming on, but again, the amount of power that you're getting from that is good, sufficient for the traditional data centers. It's going to be an issue for the AI data centers. Again, if there was one or two of them, that's one thing, but there's very likely going to be hundreds of these data centers, because it's not just the AWSs and Metas of the world that will have these AI data centers. It's going to be, to a certain extent, everybody, banks and hospitals and large corporations that have a lot of design work that they're going to do. You mentioned the example of a restaurant maybe does it to come up with uses AI to come up with a menu or how to run the building. You scale that up and you start thinking about people that are doing drug discovery. That's huge amount of inputs, huge amount of data. Let's go do an analysis of how many people took these certain medications, what environmental factors were they exposed to, how old were they, how often are they running into other people. Take all of that data and turn it into something recognizable. AI is kind of a perfect solution to go do something like that. And these companies don't necessarily want to, they don't want to risk losing control of that data. So they may not just go to the public cloud to do that. They'll build their own AI data center to run those analyses and control that data.
how are these things that we've talked about so far, kind of power, heat, space, and all that, how's that changing data center architecture and how they're building those out?
Yeah, so there's a few things going on that would change. Part of it's the kind of data architecture, but part of it's the physical architecture. First, it's the port speeds. So the data rates that these things are communicating at are rising dramatically. An AI network, the probably the slowest AI connection today is at 400 gig, which is kind of faster than almost any data, traditional data center connection. But that's already being eclipsed by 800 gig. 800 gig is already growing fast. Within a year, 800 gig will be the primary port speed. But then within a year or two of that, we're already seeing deployments going in of 1.6 terabits. So these are individual ports connecting, again, GPU to GPU. So, and a lot of these are done with parallel fibers because that's, for a lot of reasons, that tends to be the easiest way to transition to the next speed, add multiple lanes. So now you need more fibers. So instead of just 2 fibers connecting port to port, which is a more typical connection, you have 8 or 16 fibers, going from port to port. And, with these connectors, again, latency is critical. So, that the performance of those connectors that are in that link become, hypercritical. The other thing is, again, latency is important. One way to keep latency down, the easiest way to keep latency down, is to keep the cable runs short. So these networks are being built with these servers being placed as close to each other. It's whatever, Cray computers and, some of these other high-speed computers, they were doing the same thing. And I remember learning about Cray computers years ago. If you ever saw one, it was round. It wasn't racks of computers, it was round. And the reason they did it round was because it made the connection between one part of the computer to another as short as possible. Now, those were copper wires. Now we're into optics. But the same idea, keep these things as close as possible so that you can churn through this massive volume of data as quickly as possible. So we're seeing, again, a large number of fibers in a small space. So a kind of a byproduct of those things is we're seeing a bit of a resurgence in multimode fiber, where a lot of people that are, at least, passingly familiar with optics in the data center world have figured, all right, everything's gone single mode. Multimode has no place in a data center anymore. But because the runs are so short, it fits in that capability window of multimode fiber. But then with multimode transceivers, you can save a lot of power. You can get a 400 gig or an 800 gig multimode transceiver that uses much less power than the equivalent single mode one. You multiply that by the number of transceivers you need in these networks, and that can become a measurable amount of power savings. So I'd say those are the biggest things that we see as far as the change. The space is getting very compacted, and in some of the networks anyways, we're seeing some multimode fiber make a comeback.
Would you be able to explain to me briefly single mode, multi-mode? Like what are we? I think I know what you're talking about, but I just want to make sure I understand that.
Yeah, so I'd say the most practical way to explain the difference, a single mode light source transceiver, very specific. It's a very precise laser. It operates at kind of one specific wavelength. So it's very good for going long distances. It's very good for making high speed transmission.
Okay.
Multimode, not quite as good of a laser. It uses several wavelengths, not quite as powerful. Typically doesn't get quite as fast as a single mode transceiver in data rate. But because it's a less precise laser, it can be mass produced more easily, which makes them less expensive. So multimode transceivers historically are less expensive than single mode transceivers. The reason most people switched from multimode to single mode was because of distance.
Okay.
So if you're going short enough, you would keep, and if you keep going with that equation, you keep getting shorter and lower speed. You don't need optics at all. You go with copper, so you could have a category cable or something like that. So as you go up in bandwidth and up in distance, you move from copper to multimode to single mode. So the kind of the difference that happened here, at least from my perspective, is the distance part of the equation became so short. You know, not even going hundreds of meters. You're going 10 feet from one server to the other. You don't need the capability of single mode. You can live with the capability of multimode.
Okay.
And it comes with this power savings. So that becomes a kind of a strong argument in favor of multimode in some of the AI architectures.
All right, so we've talked a little bit about the power needs, and we talked about a little bit about how people are lessening the heat. Do you have anything else to talk about with how people are, working on the heat problem?
Yeah, I mean, part of it is kind of the input. So like that multimode choice would be an example of lowering the power. I would say most of the conversations around heat have to do with not lessening the heat per se, but how do you get rid of the heat? And that gets into those kind of cooling discussions. You know, are you going to use, liquid air assist solutions, or are you going to go full fluid immersion? So fluid immersion, at least from my perspective today, is a little nichey. There are places it's used, but it's not super widespread. But, with with these generations of AI chips becoming more and more powerful, that means more and more heat dense. It seems inevitable that at some point, most AI data centers are going to have at least some liquid immersion cooling going on. The part that we as a cabling manufacturer are looking at is kind of the compatibility, because there's potential issue when you take a fiber optic cable and you just sit it in this fluid bath. What's going to happen to the performance of that cable, and vice versa. The fluid manufacturers, if something leaches out of that cable, does that impact the performance of our fluid? So those are things that, as an industry, that we're continuing to look at, and I think those are answers that have to get arrived at before it really, takes off and becomes more mainstream.
Well, as we've mentioned, the demand for AI is, I don't know, exponential. It's only going to increase even more as we move forward every year. So, if I'm a data center manager, owner, or a business that's thinking about, I need my own for whatever reason, what are maybe some ways they can start to properly address, the concerns we've discussed, and how do they start thinking about this issue?
Yeah, so I'd say, the power issue is always the number one issue. So, where are you? Is there enough available power where you are? I'd say that's the primary thing that somebody's got to address. And if there's not enough, well, where are you going to go to get it? Is it close? Are you going to have to go far away? That's kind of the biggest issue, I would say, in front of everybody. From a network cabling perspective, you got to make sure the cabling design supports, all of these specific needs of an AI network. Again, you got to keep those runs short, where, traditional data center, you might have gone up and over and, make it look nice and, keep those aisleways clear. There's a lot of kind of aesthetic choices that may have been made in prior data centers. You're not going to do that in an AI data center. Keep the runs short, so the cabling's got to support that. Because it's parallel, there's going to be a lot of fibers, there's going to be a lot of runs going to multiple places. So, polarity and labeling, again, becomes hugely important, because there's a massive number of connections that people are going to have to keep track of. And to that point, you want to look at at methods to install cables more quickly. Part of that might be product choices, but a lot of that is procedural things. Who's in there? How do they do it? What's the sequence of things that you're going to put in? Do you put in structure cabling first and then bring in the equipment after? So you're doing patch cords, thinking through those aspects of it become important. And then, we were just talking about if immersion fluids are going to be used, that's going to be the cooling of choice. You got to pay attention to the compatibility of, whatever materials are going to be exposed to that fluid to make sure that, it's going to operate as you expect it to. Those are the things I think, those handful of things would be what I would advise any data center manager to be thinking about at the very beginning.
All right. Well, hopefully those things help someone start thinking through this problem as we move forward into this. So I appreciate that and your time and all that. But I would like to close out by refocusing on the why of what we do. So what motivates you to do this day in and day out? What keeps you excited and passionate about what you do?
It's an exciting place. I mean, that's people have been saying for a while that data is the new gold. So when you think of data centers, they're the processors of that, valued commodity. And that's been driving the global economy for years now. And that in itself was pretty interesting. But now with AI over the past, say, 2 years and kind of the foreseeable future, next 5-10 years, there's this huge acceleration of that. And it's AI and AI processing. It's so new that it seems like things are changing constantly. So if ever there was a time to be involved in trying to develop a better mousetrap to solve somebody's problem, today seems to be that day. So it's pretty exciting to work on this stuff every day.
Yeah, I agree. It's for me, it's been fun learning about it from you and from a few others that have educated me on AI and where we're going and what, how we compute it, right? Just the basic thing that needs to happen for us to have the advantages of it. So, Mike, thank you so much for taking the time to be on the show and for sharing your knowledge with everybody. I appreciate it, and I look forward to talking to you again. Thanks.
All right. Appreciate it, Todd. Thank you.
That was my conversation with Mike Connaughton, Senior Product Manager, Network Solutions at Leviton. You can connect with Mike and what he's working on by heading to the links in the show notes, including a link to a webinar where Mike dives into more details on solutions that can help with heat and space challenges facing data center managers as they accommodate for future data processing needs. I would love to hear how you are using AI in your job and the impact you think it'll have on your job moving forward. You can let me know at podcast@graybar.com. If you enjoyed this episode, you can help us grow the show by subscribing and leaving a 5-star rating on YouTube and on your favorite podcast player. Thanks for listening to this episode of Keeping the Lights On. We'll see you next time. What advice would you give to 18-year-old Mike?
Yeah, I think about myself as 18. I actually started college. I was a little young when I started school, so I was 17 when I started college. So I was 18. I was in my freshman year.
Okay.
So I think about my college years. And, the biggest thing I'd say was kind of stay the course. Because I remember being, certain things kind of distraught. Things aren't going right. But, things I've learned over time is you really have to pay attention to a couple of things, a couple of important things. And as long as those come out right, the rest of it's kind of noise. It doesn't really matter. I think I figured that out kind of by accident as I went along. But I can't complain about the way my life has turned out. So,
right.
Even if I don't get a chance to go back and give myself the advice, I think I'm pretty happy where I ended up so far.